Okay, so this lecture now is on integration by parts, which is the reverse of the product rule of differentiation, and then I'm going to do some substitution. Okay, so integration by parts, remember, is, as we say, the reverse of the product rule. So if I've got two functions times by each other, the derivative of them would be the derivative of the one, and so on. This would be the formula. So if I want the integral of this, that would surely be just f of x times g of x equals integral of this plus the integral of that. And if I changed the subject of the formula, and let's say I made this the subject of the formula, it would be equal to f of x minus that. Okay, so that's the formula we're dealing with every single time. And it's quite a cool concept. All right, so when do we use this? Is if you've got two functions times together that there's nothing else that you can do, right? So in other words, I've got an f of x times by a g of x. The one's not a dude and the other one's not linear function. I've got two actual functions. In other words, the reverse of the product rule. Okay, so here I've got x times by sine x. It is definitely two functions multiplied together. Yes, there's nothing else I can do other than integration by parts. Okay, this one over here that's a power function, and that is the derivative, or with minus a 2, but I could put the 2 in. So no, that's a dude scenario, right? This one is linear, so this is straightforward. Bring it up and 1 over 2, and I'm good to go. Okay. This one is x. Now, if I bring this up here, this is going to be, the dude is not next to it. So what do I need to do is I could definitely use integration by parts here, or I could actually use substitution, which we will do. Okay. This one over here is two functions multiplied together for sure, but we've got an option for the sine of a different angle times by the cos of a different angle. It's on the formula sheet. Something like this. This is two functions. This is not the dude next to it. It is definitely two functions multiplied together. So yes, this you could use integration by parts, all right? But you could also, again, use substitution. This is a function, straight line, times by the cos of x. So that is definitely a function times a function. We want to do the reverse of the product rule, right? So yes, but if I had something like this, what is this? This is the cos of a linear. So this is straightforward from the table just by inspection. Okay, so let's look at some examples. Let's look at x times by the sine of 2x dx. So when we're looking at that, we're going to go, okay, we want to use this formula. All right, so the trick is that we want to let one of them equal f and the other one equals g. Now, 99% of the time, you want to let your f equal the simplest one, the one that when you differentiate, I just get a constant, okay? So f equals x, so that would be equal to x, and my g dash I would let equal sine 2x. So that's that scenario here, okay? All right, now I want to find the derivative of that, so that's going to be 1, and then the integral of that, and that is easy. I can use my table, and I know it's going to be minus 1 over 2 cos 2x because it's a linear. Practice this, guys, so that it becomes easy. Okay. Now I want to write this out like that. So I'm going to go this. So integral of x sine 2x dx equals f times g, here it is, minus the integral of 1 times by g. Okay, so I'm sitting with this scenario here. That is nothing to do to it, so I'll just multiply them out. This one is going to be, I've got a linear function here, so I want to go, cool, this is going to be 1 over 2 times 2, so it's going to be a quarter sine 2x plus c. Okay, nice and easy. Let's look at ones like this. So you've got 2x over the root of 2x plus 1. So I'm going to take that 2x plus 1 to the top, and I'm going to let f of x equal my 2x, and I'm going to let my g dash x equal the other function. Okay, so now my derivative is 2, and my integral of this is 2x plus 1 to the half. So how does that work? That's linear, so that's 1 over 2 times by minus a half plus 1 gives me a half. They cancel each other out, and I've got 2x plus 1 to the half. Okay, now I'm ready to write it out. So I'm going to go, cool, this function times this is equal to f times g, I put it together, minus 2 times by the integral of that. Okay, this is linear, so I'm going to be dividing by 2, and minus a half plus 1 gives me 3 over 2, so it ends up being 2 over 3, and so on. Okay, so that it is actually really nice to be asked this. It's worth lots of marks, and I would practice as much as possible. Okay, so let's just quickly run through, and this is where I suggest what you do is you don't have to necessarily do something unless you haven't practiced it. But if we have a look, just to be able to look at it to know what you're going to do. Okay, so for this one, you might need to pause the video to be able to have a look at it. But this is going to be quite clearly, it's a power function, derivative next to it, and I'm just probably missing an angle of 2 there, so I need to compensate. Okay, this one is straightforward. It's linear, so it's going to be basically a third sine 3x plus c. This one, I've got 2 functions, but they're sine and sine, different angles, so I go to my formula sheet and I just chuck it into the compound angle formula. Okay. This one is sine squared, so therefore I'm going to make it sine 4x times sine 4x, and again go to that formula on my formula sheet. This one, cos cubed, is going to be split the cubed, so I'm going to get cos squared 3x times by cos 3x, and then I'm going to change the cos squared into 1 minus sine squared 3x. Here I'm going to manipulate, and I'm going to change sec into 1 over cos, so I end up with cos to the 7x at the bottom, and if I bring that up, I'm going to get cos to the negative 7x. Here I've got a dude scenario. Here I can do integration by parts. This is definitely integration by parts. And this tan squared 2x is on my formula sheet is 1 plus tan squared theta is equal to sec squared theta. Okay, so just get used to whenever you see a list of these things, just have a look at what you would do, what you would do, what you would do. Okay, so let's just quickly look at integration by substitution. For this one, it would be a bit crazy to do it because you've got a dude, but let's say you fixed on it. So if you let u equal x squared minus 4, that means du dx is equal to 2x, so du is 2x dx, which is what I've got over there. Okay, so now I can replace my integral. I know that u is x squared minus 4, so that's the root of u, and I'm replacing 2x dx with du. All right, and now I find the integral of this, and I substitute my u back in, and I've got my solution. Okay, but the dude is a lot quicker, so please get used to it. This one, on the other hand, you could have done by parts, but integrating by substitution is also an option, and probably a better option. Okay, so if you let u equal x plus 1 here, then du dx is equal to 1, and dx and du are then equal to each other, all right? And then I've got to change the subject. I want to replace x with u minus 1. So x is u minus 1, x plus 1 is u, so it's got root u, all right? And so what am I going to end up with is I'm going to simplify this, split this up, and I've got u to the half minus u to the minus a half du, and I'm going to integrate that and then substitute my u back in. Okay. Right, then we could have the integral of 1, the root of 1 plus root of x dx, which is quite a difficult question. But using substitution, they could give us a substitution. All right, so the idea is if they give us substitution, we have to use substitution. So you've got u equals 1 plus root x. All right, so we're going to follow that. We're going to go, okay, well, I actually want to find out what du is, all right, so, or dx is, sorry. So I want to get x on its own. So watch here, I'm going to go x equals u squared minus 2u plus 1. So dx du is going to be 2u minus 2. And so dx is that, all right. So what I'm going to do is here is I want to replace my dx with what it's equal to, okay. So I'm going to look here, and I've got 1 plus root x, which they've told us is my u. So I've got the root of u, and then dx I'm replacing with 2u minus 2 du. That, okay? And now I'm going to just multiply out, and then I'm going to find the integral of that, just simply, and I'm going to replace my u with what it's equal to. So I've got 1 plus root x, 1 plus root x. Okay? Have a look at it. If you find it complicated, then feel free to ask.